For the past week and a half or so, I've been working on this thing right here. So I actually wrote this little kind of what I'd love to do thing a couple of years ago, but I only got to this network rendering part. Started doing it a couple months ago, but now we're making some progress. So I've been working on basically just figuring out the protocol, how I want that to work, and the actual transport, since we don't use any libraries for doing, we don't have anything on top of TCP other than what I wrote. So it's been a little tricky figuring that out, but now it kind of works. So I think I had a very distinct idea what I want to do tonight. So we're going to do that. So let me show you where we're at, and then I'll tell you what I plan to do. Let me put this out of the way here, and actually I'll pop a shell here and stop a little task here that's running. I'm kind of mining crypto on the background here. Okay, so as specified by this document I wrote in 2018, I've been thinking of doing clustered rendering for CUA for a while now, which would be really cool if you could just string up multiple machines to do a single render. It would make my life easier because I have a bunch of machines here, but right now there's no way to kind of hook up together to do a render. So yeah, the basic principle here is like the user interface is clear. Like you fire up a bunch of these worker nodes on your network, they report their IP, then you configure that in like a master node, and then that kind of just choreographs the whole thing. So what I have right now is I have a bunch of code in this feature network rendering branch, which make this a bunch bigger because I've been working on my own. So yeah, there's a bunch of commits there that I've been doing, just sketching this out. It's very messy at the moment. It's all kind of stuffed in these two files here, networking.c and protocol.c. Obviously, once it's done and kind of working better, we can break that out. Sorry about that. That's my radio. Another one of my hobbies, my amateur radio that I've been playing around with. So yeah, it's kind of stuffed in the single file here, and then the idea is to break that out once it kind of works. So yeah, there's a bunch of code here to do to implement the protocol. The way it works is we have a simple transport. Correct me if I'm wrong with the terminology, but like a application protocol on top of TCP, which is super simple API, just chunk send and chunk receive, which splits the data, you give it into chunks, and then sends that over a socket to another machine. Very, very simple. Like I just wanted to bare bones simplest API I could have. I'm sure there's a lot of bugs in here, vulnerabilities and stuff, but it kind of works. So, and I've been testing it with like large amounts of data, and it seems to kind of work. So I'm happy with that. I chose port 2222 for now, and the chunks are 1 kilobyte in size. So that's what we use for transport. And then the actual data that we send across the wire is just JSON. Basically, I have the CJSON library here, which is useful for working with JSON, encoding it, decoding. So we use that heavily here. And then the other component is if we need to send like, I mean, I'm sure we could send it as like text inside JSON, but just to make things easier and not have to worry about it for now, I use Base64 encoding for all the data that we pass inside the JSON. So instead of just putting in a string and then having to worry about escaping it for JSON and stuff, I just Base64 encode it and stick it in. And the implementations for those I stole shamelessly off Stack Overflow. There's a good answer kind of saying like what's the fastest decoder and encoder, and I chose the fastest ones. So hopefully that's okay. I didn't find a license for this one. But okay, these are tested and they seem to work pretty fine. So right now, let me demonstrate what this does. So if I set this up to be a worker, and it is, so if I start this up as a worker, I can show you here as well. So if we compile and then run it with the worker, and this is already bound. --worker flag, the -v is just for the debug messages, and it'll just listen on port 2222. So we're gonna set this to listen on here, and then on here, and then C-rate input str.json, and then we can specify all the settings just like you normally would, but then we can specify options with like -workers, and then here you can add comma separated list of IP addresses for now. Whoa. My desk is a bit of a mess. We'll just specify localhost here, and it'll load up the assets like normal, set everything up, and then it did not do what I wanted it to do. Why is that? Did I mess up the args? Why did that not work? -workers. -nodes. Okay, I messed that up. -nodes. There we go. So now it'll load the assets, and then you'll see stuff happening here. And it crashes. That's hilarious. Okay, what happened here? String concat. Okay. I've done a bunch of changes here. Let's see. Asset path. HDR. Oh, right. Yeah, I messed up the encoding, I think. Value string. Okay, what's... Yeah, string 1 doesn't exist. Oh, okay. I guess that's gets set to null or something. I just recently pushed the changes from my laptop, so I think I broke that in the previous commit. Let's see. Give me this one. What did I do with the asset path? Nothing? Oh, okay. Why is this not... Okay, I guess we're jumping right into it then. I'll explain what I'm gonna do, because I had a distinct idea of what I want to do next, but I'm gonna debug this first, I guess. Yeah, parse JSON. Where does it get set? Asset path. Press, and then reset the asset path, which is null. Okay, let's see, JSON parse. Let's see, asset. Find out where it gets set. Okay. Parse ambient color, yeah. It's kind of note we're not setting it anywhere. Where did we use to set it? That's kind of weird. Yeah, I guess here. Oh. No, what happened here? This has never happened before. Welcome to debugging your own code. Okay, so we set the asset path here, obviously. Input file, that's set. Path arg. Weird. What happened there? So we'll set this as a main master node thing. Okay. First asset path. Input slash, okay. So where does it get set to null? That's kind of weird. Okay, so it works here, but not here. And that works? Okay, that's curious. Let's set this back. I'm assuming there's going to be like a different code path for... So you see here, it failed to connect to nodes, so let's do that again. Okay. Oh, right, it's the worker that... Okay, yeah, right. Okay, I forgot about that. this makes more sense. Okay, so it's asset path is okay, yeah, I know what's happening right now. Okay, so that didn't manifest before. That's fine. We're gonna ignore that for now, I think. How did that not happen before though? So okay, yeah. So what happens is when the master node starts up, stop that. It basically detects there's 2 code paths. If it's a worker, then it'll go here. Otherwise, it'll load up all the assets. In here, it tries to sync with the clients, which it'll just build a client list. It'll check the connection to each one of them. If it can connect, it'll return that client and then the list of clients. And then it'll start up a background thread for syncing with each of the clients. And here you see it, yeah, it connects, and then it'll try a handshake, and this is all in JSON. There's a bunch of wrappers for like sending just JSON, bits. Checks the warning errors and stuff, and then it'll send the scene. So what happens is it stashes the scene JSON that you give it into the scene cache string here when you load up all the assets. I tried multiple different approaches. First, I tried to just load up all the assets and then sync up the state, like okay, take the render struct and encode that, and then send that over the wire and stuff like that. But then that became a lot of work to encode all of this, platform specific stuff into something that's like a common format. So I started rethinking it, and then I decided to, instead of doing that, we're just going to pass all the same things that the master node loads from disk to the worker nodes. And that's what we're going to work on tonight, or at least try to get working. So the JSON is easy enough. We can load it from disk in the master node, cache that into this bit right here, and then send that out later. Like I just showed you, it'll just get that scene cache, parse that out, send that out to the clients. But if we look, input HDR, if we look at this, it references a bunch of files, and it looks like my, let's see if we can get this working. It references a bunch of files, which is okay. And the approach I tried with this is, okay, we're gonna load up this cached JSON and then just see if there are files in here, and then Base64 encode those and put them into the JSON. I just deleted all that code before I started recording this video because I thought of I don't know if it's a better approach, but it's at least a different approach that doesn't require me to like rewrite the whole scene asset parsing thing, which is we're gonna make like a file cache. So when the master node loads up files from disk, it'll cache those into like, I don't know if it's a key value store, but basically key, which is the file path, and then value being the file contents. And then that gets sent along with the JSON to the worker nodes. And then the worker nodes will be like, oh, I'm a worker node. I'm not going to load these from disk. I'm going to load them from the cache. So we're going to build that and see if we can get the crash solved while we're at it. So this is going to be a new thing here. Again, we're going to make a new file. I'm just going to call it fs cache. It's not really a file system cache. File cache. Put this in here. And the API for this guy is going to be fairly simple. So we're just going to pass in path and then the data. Should we pass in Base64 encoded data, or we'll just pass in the data? Okay, data and then size t length, something like this, and then load from cache. And then size t length, and then something like encode cache. which will do the final encoding. I think it'll just return JSON actually. We'll see what we want to do. Either way, we want to see encode file cache. Something like this. Does that make sense? So the idea would be that inside each of these, because we have this kind of hacky arc system, which we can use to set like these tags, set database tags, and then we can check those wherever we want. It's sort of like the parameter equivalent of like the long jump. It's kind of not nice because you set these in some random place and you check them in another place, but they're useful for like global settings. Like if you want to override parameters on the command line, you can do it from here, and then it just sets these tags and they're checked instead of being passed around as parameters or stuff like that. I just made the design a bit simpler, I think. Hopefully. But yeah, the idea that we kind of call these all the time, but then inside here we'll check that if this is actually a network renderer, then we'll cache it. Otherwise we just ignore that. It's a no-op. Does that make sense? So when we load up a file, we're working with a network. Yeah, 'cause we have a common API for loading files here. This should really be a file path. Yeah, so this loads a file. File path. Thank you. So we can have like a check here. If we're doing a network render and we have like clients and stuff, we can cache that. I think that makes sense. So like args, use clustering. So in here, it's kind of hacky, but include args. So we load up the file, alloc read bytes. Yeah, and then here, if is set. What was it? No, use clustering. I should probably change that name. And then we'll have the cache here as well. Cache file path, and then buff, and then red bytes, something like that. Yeah, and then the API for file cache.h. I think, yeah, we'll keep this as a chart pointer for now. This will return JSON, but it will be encoded in a string, I think. I don't want to include JSON stuff in the header here. Okay, I think that makes sense. Yeah. Start implementing this. Let's do that. See what comes of it. So, how should we implement this? Let's see. Oops. Encode file cache. So we're gonna have some kind of data structure here, like a key value pair. Okay. Struct file or something. Path, and then void data size size, something like that. Now we'll have like an internal state here. Something like this. We'll see what comes of it. We don't have like a list implementation in C Ray yet, so we're gonna have to do like manually. We'll see how that goes. Okay, so that. We do this list stuff in, where did we do that? Vertex buffer, I think. Yeah, we initialize them here. I'm just gonna cheat. Poly BVH. Wait for it. Here we go. Yeah, we just re-alloc. That's how we do lists in CRA. It obviously we could make like a simple API for doing generic kind of lists or arrays, but I find that not having that kind of makes me kind of reconsider, like, do I really need a list here, or could I do something else? Because this is obviously a pain in the ass. Yeah. I think that makes sense. Actually, we can realloc. No, whatever. We can do it like that. So we're gonna need CJSON here as well. Library CJSON H, and we'll do this first. Create object, and then do the easy stuff first. Actually, we want. Can we specify a JSON like starting as an array? Can we do that? Maybe we can. Just get a like a JSON linked thing. I keep forgetting this stuff. Okay, so is this valid? It's valid. Okay, so we can just do array. Okay, cool. CJSON create array, and then add string to object. And then we're gonna do data Base64 Encoding. We're gonna need that as well. Kills Base64. Actually, we don't need to do that. Base64. There we go. Encode. Cached files dot data. Files dot size. And then this is gonna go here. So we're gonna add it to the file. Rename this to like file record or something like that. And then this is gonna be the path. So no idea if this is gonna work, but I think this makes sense. Because like the whole asset loading system is obviously heavily written to assume that it's loading stuff from disk. So this way I kind of get around having to rewrite all that. It's not ideal, but it'll work for now. B64 data. Don't know why I keep typing 643. Does that make sense? And then here we're gonna return JSON. Wait, so this is gonna allocate stuff, right? So return. We're gonna do CJSON print unformatted file cache, and then CJSON delete file cache, and then return final. Something like that. I think that makes sense. Right? I think I'm gonna do this instead. So realog cache files. Something like that. I'm just gonna wing it real quick here and see if how broken we make it. And then cache files. File data is data. Wait, do we want to copy this data over? Yes, we do. We do, yeah. String, I have some utilities here we can use. Include string.h here. My custom old thing. So path is string copy path. And then data is gonna be mem copy, which is where? It's in string.h, the actual one. Oh no. Glad you can do that. Okay, mem copy. File data length, something like that, and file. Maybe like that. So we pre-increment this, so we don't have to do like the first allocation, hopefully. And then we just subtract 1 from the index to get the current index. I think that makes sense. So it starts at 0, and then it's 1, and then... yeah, okay, I think that makes sense. And these are both pointers, so we just copy the data into here, and then... cool. We're also gonna need a function to destroy the cache. So we can destroy it right after we've sent it to all the clients. So void destroy file cache. Cool, something like that. This is generally how I do this kind of stuff. I just kind of rapidly sketch it out so I can start building an idea of whether or not it'll work or not. If this seems derpy, I'm sure that's a valid concern. Yeah, okay, so... yeah, we're just gonna walk the list and then free them all, and then starting to think, do I have better data structures for this? I might have. I have the block allocator, which is pretty nice. You can literally just allocate memory on this and then free in a single call. Ooh, maybe we could do this. I think we're gonna do this actually, because this simplifies the freeing a bit. Does it? We'll do it manually for now. Can always refactor it. So cache files i.data. i.data. something like that, and then free cached files, free the structure itself. Something like that. Because like I use the block allocator for everything else. Well, a lot of other things in C right now, and you don't have to write these bespoke destroy thing. Instead, you just call a single destroy blocks thing, and it'll free all the memory for you, which is pretty nice. That's used for the node system at least. Can't remember honestly if it's used for anything else. But okay, yeah, load from cache. This should be fairly simple linear search. We're assuming this is not going to be millions of files. If it gets to that, then we have a hash table implementation we can throw in here and use that. But it's just going to be a linear search. Path file cached files i.path return data. Then if length is cache files size. I should be more consistent about this terminology. Is there's length and then size. So should we? Yeah. Oh no! Don't do that. C-Ray's refactoring is not right. Xcode's refactoring is not very good. It's pretty derpy. I think this works. Just return the data pointer and then the size. Just throw it in here. Rally abort. Otherwise, it's probably gonna complain. It's not. Okay, I'm just gonna return null here. I'm sure it was gonna complain, but apparently not. Oh. Full string equals. Yeah, okay. I should really have stable here, so we have to include that. That's a fairly new practice, but anyway. Does it really not complain if I don't have this here? Yeah, it does. It just was worried about the Boolean thing. Okay. So here's our very, very simple file cache implementation. Every time we load a file, if we're doing a network rendering thing, when we call load file, we will call this cache file thing. It'll cache that. And oh, we need to allocate this, of course. Length, just length. It'll store it in here. And yeah, I think that'll work. Maybe. We'll just dump the file cache here and see what we get. Yeah. Also, we're gonna need a function for decoding the file cache so we can actually populate this stuff. Of course, yeah. Decode file cache from the given so you know, this is on the master node side and this is on the client side, right? So and then we can just use the cache file function, right? Yeah, so we don't have to worry about allocating that. So cjson for array for each. So record and cache cache file. Yeah, you can do it like this. And and that's gonna be cjson get object item. Hold on. Oh no, wait, cache file. We don't know the string, do we? Because yeah, we can't encode it like that, I think. Because right now it's something like, it's gonna be like the path to file and then, you know, base64 crap. But we don't know this path to file at all to look it up. So we're gonna, yeah, we're gonna change this format a bit. Hopefully the microphone's okay. I set it to the side this time. You're right. So record, create the object, encode, and then yeah. So you're gonna do cjson add string to object record, and then path is gonna be the cache files path, and then record data right there. Okay, there you go. So now we know the structure there. Okay. Path is cjson get object item. From record we get path, and then oops. We get the data. There we go. And this is all kind of assuming that we don't have malformed stuff. Since we're the ones both encoding and decoding it, we can kind of make that assumption, I think. I think it's a fair assumption to make. Cache file, which takes the path, value string, and then the oh, we need to decode this data, right? Yeah, we need to decode the data. Decode data value string. Not sure why we have this input length parameter here. It's always strlen data value string because it's just a base64 string, right? And then data len, so like this. Oops. And then this is gonna be data and data len, right? Oh. Oh, come on. Something like that, right? Decode file cache. Yeah. Then we gotta worry about free stuff, so this gets copied, so free decoded. Same deal here. Free B64. B64. Let me rename that actually. Encoded. Oops. There we go. I think that makes sense. This is global state inside here, which is not ideal. I try to keep that to a minimum. I think that's fine. And again, on the client side, once we're done, because this will be fairly data intensive. Once we're done loading up these assets on the client side, the worker side from this cache, we can also destroy it on there as well. So yeah, that's fine. Stick this in here, right? And I think that is starting to shape up. I guess we'll try that next, right? We'll just dump some JSON and see what we get. Yeah, let's start testing it. So in load file, first of all, args.c, if we use clustering, I think we already did this. Yeah, if you use clustering, we're going to cache the file buffered bytes. Cool. And once we're done doing that, load scene. Let's see, let me think. So we've done parsing the JSON, which means that we're done doing all the assets. Here we can start thinking about this. So we'll set this as a master node again. Make this listen, maybe. There we go. Ooh. Oh. Okay. Cache.h. Unknown type name, size t. Where's that defined? Size t.h. Maybe like that. Xcode is way more lenient about that stuff. We'll do verbose as well. Actually, this should not be a debug message. This should be info. Right. We don't need verbose here. There we go. Okay. Let's start thinking about this. So we have the breakpoint set, I think. There we go. Let's see. We don't have the file cache here, do we? Can we just do this? I think we can call any symbol from here. Bad access, okay. Let's just write some code to just test this out. File cache, encode file cache. We'll just see what happens. Okay, we have bad access. Why is that? Okay. Probably passing in null. Or the size is something. Something dumb. Like this data is invalid. Data pointer size is pretty big. HDR, let's see. HDR.json. I guess we'll cache that as well. I don't care about that. The size is not correct, that's for sure. That's gonna be 8 kilobytes. Yeah. 5.3 kilobytes, so yeah, it's tiny. It's definitely not this big. Oh, we don't populate the length. No wonder. Okay. Derp. Length. Size. Length. There you go. We run that. Cool, that worked. Test is an empty array. Why is that? Let me think. Okay, did we never hit the... Is this broken, or did we never hit the cache file thing? Yeah, we did hit the cache file thing, of course. Okay. What happens here? Seven files. Yep. Yeah, this looks good. It looks fine. right? Create the array. Oh, we don't add it to the array, of course. Derp. Add item to array. And the record. So little mistakes, that's fine. Cool, let's print that. That's looking more like it. So we got an array with path, input HDR, and then the data encoded in Base64. Cool. This just, yeah, it doesn't print the whole thing. If we wanted to print the whole thing, we could print off it, but I trust that it's correct. So now we can send this bit over to the client, and then the client in load file, we could probably hook it in there, so we don't have to make any changes, right? Yeah, load file is the thing, I think. Yeah, same thing, load file, we can hook here. I'm thinking, is there going to be any side effects from this? JSON's going in unmodified. Like before, as I mentioned, I was trying to just patch the JSON with all the data in there, but that quickly gets out of hand when you think about the fact that if you load up a mesh, which is a wavefront object file, that file then can reference one or more material lib files, .mtl files, and then each of those .mtl files can reference one or more textures or other assets. So there's like at least 3 layers, and in the future I'm sure more layers of kind of depth to loading the files, and then you have to parse it. I started writing the code today to do that, and then I quickly realized that that's like horrible code, and then it kind of made the whole asset parsing really messy. So yeah, that's why I think this is at least like a good stopgap for getting this thing up and running, so I can start doing some clustered rendering. But not sure if it's gonna stay, but we'll see. Okay, so let's first of all deal with sending this over to the client. So handle client sync. Make the handshake. We're gonna first want to send in the asset. Send assets. CJSON. Let me think here. Yeah, okay, so assets, yes, CJSON. Parse. We could just chunk send it. We don't need to parse this actually. Send client, and then get the no, file cache. We don't need this. Is this fine? It's not fine, but these // utils are kind of derpy because we're in the directory. We'll deal with that in just a second here. Let me do that, and then I think I can just yoink like /utils like that. Will that work? Oops. Maybe like that. Yeah, it's fine. These kind of need work. Okay. Back to where we were. So chunk send. Encode file cache. And we'll, this will allocate stuff, right? Yeah, sorry, need to free that. Chunk to send. Takes the data. It does not free it. So if we use the send JSON abstraction, that will actually free the JSON that you give it. But with chunk send, we're gonna have to encode file cache, and then yeah, and then free cache. We'll read the response right away. Send JSON response is read JSON client. That will deal with all the possible fallout. Yeah, this is still response text is no. If it has an error, find sync error. Yeah, I think we'll do this. Yeah, that makes sense. Yeah. Client asset sync error. Oh, client socket. Free response texts. Do that. I think that makes sense. Logger debug sending assets. We'll do a little debug log here. Sending scene. Oh, there it is. Let's remove it up here because we don't want to encompass the whole thing. Response, yeah, okay, I think that makes sense. And then for the response, we're gonna have to handle that JSON. Yeah, send that. And then we're also gonna have to we're gonna have to wrap this up in an action. Right, I forgot about that. Yeah, we're gonna do it like this. Sets new. Come on, new. Come on. Oh, it's create. An object. Add. How do we want to structure that thing? Yeah, so we're gonna add string to assets, and this action. This action just tells the client what it's supposed to do. It'll match this in a list of commands, and I think the list is up here somewhere. Yeah, load assets is gonna be load assets. And then CJSON add item to object, and it's gonna be assets, files, and the file cache. This is derpy because now it's like encoding here and then decoding it here and then passing here where it gets, yeah. That's fine for now. I don't care about that. And then send JSON client assets. What do we do here? Scene. We don't even delete the scene here, do we? Oh, right. Send JSON will handle freeing this. It'll delete the thing there. Oh, yes. All these APIs need a bit of work, and this code for like doing this kind of protocol stuff is very dense and kind of annoying to read. I'm sure it will change a lot, but I'm just trying to get it to work for now. So send assets. Yeah, okay. That's fine for now. Does it build? Does not. Free cache. Don't free the cache. We don't have that anymore. Make. Okay, so we will run the receipt. Oh, we need to actually hook this up as well. So load assets needs to be a command on the client side. I keep forgetting this. I've been, for the last 5 years, C-Ray's been like a single program. I implement a feature and I test it. But now there's two instances of C-Ray running, the client and the worker. So I have to write 2 bits of code before testing. So load assets is going to be command number 2. It'll match worker command. Here we're going to do case 2, return save assets, JSON break, and then receive scene takes this one. Yeah. So see JSON get object item JSON files. This is gonna be an array, and then this we will hold on. I should forget what the API was like. Decode file cache. So we're just gonna put that as I might just put the CJSON in here because now we're decoding and encoding needlessly just to have this pretty char interface, and that's useless work, but whatever. Files. This should be the array, and then decode file cache data. This does not. Free data. This is a rough draft, obviously. Return new action. Okay. There's not a lot of error handling in here either yet. There's a lot of things that can potentially go wrong, and also I have not tested much. If it like loses connection in the middle of this stuff, I think it'll just disconnect, and yeah, there's a lot to handle here. I think we can test this now though. So we'll set this debugged variant as the worker, I guess. Let this run here, and then we will. Let's see, do we have one? There we go. Maybe it'll work. Connecting the client, start sync, and assertion failed. Yeah, it still doesn't like the ambient color thing. Why does this? I swear before I started recording, this was fine. Okay, let's see what the problem is. So main, we set the thing start renderer. No, set it in. Let's see, input load scene from buff. Load scene sets the. Oh, we don't need this anymore. Forgot where it was set. Right, because we don't. Set asset path. This is gonna be a bit of a weird thing, because we're not gonna have the asset path. I'm just gonna hack it. We're gonna need to strip the Are we gonna need to strip that? I think we're gonna have to pass this in. along with the JSON, I think. So we need to preserve the... I'm gonna hack it for now, but we need to preserve the actual relative paths somehow. But I think we can get rid of the asset path. When we store into the file cache, we can just strip it there. I don't know how I'm gonna do that yet, but yeah, on this side, yeah, so it's like if is set I keep forgetting is worker string copy, and then it's gonna be input slash for this hack else. Something like that. Hack. And then init render sets the asset path. That's fine. Main.c will call that right away. Interesting. Right, it uses the actual arguments. Okay, that's just kind of derpy. Basically, if we've loaded the JSON from input, we set it to where we loaded that JSON from. So in this case, it'll take a look at this, and then, okay, it's going to set it to input slash. Otherwise, it's dot slash. If you pass in the JSON from like standard in, it'll assume the current working directory. Which, yeah, we're going to have to deal with that. I think this is going to be fine, though. I'm going to reset this. And recompile that. Yeah, okay. String concat again. How's that null? Load scene. Parse JSON. Worker server. I'm confused now. Why is that null? Receive scene. New render. Oh, okay. This is a main.c. Okay, now this is getting init render. Okay, yeah. So we call this, and then we need to call asset path. Set asset path. Forgot to do that. But we can't, since this is assumes the stay. Right. Okay, so we're just gonna move this hack elsewhere. Good. Get rid of this. Put this here. Yeah. There we go. There we go. I think that'll work. For testing, at least. Yeah, look at that. Cool. That actually worked. Responding action okay. Cool. It just synced the state properly. Obviously, it's not going to cooperate with the render because I haven't written that yet, but that works. At least, yeah. Mesh offsets look fine. There are no errors. Wow. What? Wait, hold on. What? I don't recall. I haven't hooked this yet. Oh, right. It's just loading them from disk, right? Because we're all are on the same system. They just happen to be in the right places. I haven't hooked load file yet to do the actual file cache using yet. That's funny. I was just like, how did that work? Of course it did. Cool. Okay, so now we need to hook up the file cache. So load from cache. So if is set is worker. This is still kind of influx. I don't like hooking like generic load file stuff like this because this should just load a file. It shouldn't do, hidden stuff like this, but this will all be figured out. So first of all, see, these tags are not strongly typed, so I have to always check is worker. So if we are at worker, and at this point we have received the assets, so we're just gonna do return load from cache instead. File path, and then this is gonna give us the length as well. Yeah. Bytes, something like that. You don't even need the like that. Yeah. So if we are a worker, it'll load from the cache, and hopefully it'll have the same kind of output as it did now. So yeah, basically no errors or anything like that, right? So we'll set this to run, and fingers crossed. I'm gonna assume it's gonna segfault or something, so let's not get our hopes up. Sync up. Oh, look at that. That's cool. Totally worked. How awesome is that? That's our file cache working. Yeah, 6.29 megs. No errors. Unknown statement that was there before. Empty line, whatever. It's a bit noisy because I got the verbose thing enabled, so it shows the node system spam. That's very cool. Really cool. So now we have. So I've spent many hours like thinking about this, implementing all the garbage code to like hack into the asset loading system, like all the different possible scenarios of like, oh well, now we're 3 levels deep, and this object file loads from this Mattel file, which loads from these 3 PNGs, and I was like way in over my head. And now this system, it's not like pretty, I would say, but it's simple. Like just, file cache. Then we encode that, send that over. That's all the assets, and the workers load from there. Obviously, a lot of this could be improved later on when we kind of get this to be more mature, and the protocol gets to be less ugly. We can add compression and stuff, all sorts of things. But I think this is pretty big because, like, if you think we're taking the files and then just Base64 encoding that, which makes, I don't think you can compress Base64 encoded data. You have to compress it first and then Base64 encode it, which would be something we could integrate to the encoders themselves, like wrap them around like a compression routine or something like that. So that you always, compress and encode, and then decompress and decode and then decompress. Yeah. But this works, I think. I mean, is there any way we can like verify this? I mean, we could, let's see. Process command. Receive assets. Once we're done, we could just dump this, right? Print, whatever. I think it works. Since there's no errors and anything like that, maybe we could, you know what? Let's test this out. I'm gonna bring out my laptop and see if it actually works on like a different system. I haven't tested that before. Should we do that? I think I'll commit this. I'm on a branch, so it doesn't matter if it's not perfect yet. Well, yeah, let's commit this and I'll pull out my laptop and see if we can get something done. Okay. Action, receive assets. There's a plenty of stuff that could be cleaned here. Close and disable notifications. Okay, yeah. So let's commit this. File cache. Yes, yes. Yeah, that looks good. Cool. That's annoying. That's one byte off, but whatever. Cool. Pull out my laptop. See if we can get this working. Okay, get pull. There we go. Then C-array dash dash worker dash V. Okay, so it's listening, and I have to check my IP manually. I haven't written that code to check that, so it's 192.168.1.219. So make. Okay, so this is the first time I'm actually trying this over the network instead of just on the localhost. What was that? 219. Like this. Let's see if things happen. Actually, I haven't tested this a single time over the network. You can't see the laptop display, but you can see what's happening on the. It should show the responses. I'll add the verbose flag as well. Okay. Here goes nothing. Holy shit! Okay, it crashed. Okay. Well, that's fair. Response. Couldn't parse incoming JSON. Okay. Asset sync error. Okay, the logs are pretty good. Asset sync error. Couldn't parse incoming JSON. This response is like a debug thing, so it just prints that up. Okay. But it connected. So that's cool. Yeah, and then it crashed and burned. Let's run this in Xcode so we can actually we're going to run this on Xcode here as well, so I can debug on both ends. So let's do this. Edit scheme dash dash worker dash dash v, so I can debug both ends at once. There we go. Listening. Then this one will set to be a master node. There we go, and we'll change this to be the actual IP. 219. There we go. Let's run this. Oh, that didn't work. Why did that not work? Don't have the dash dash worker there. Looks like that one's actually like, yeah, if you set dash dash worker and nodes, it'll just override. Okay, crashed on both ends. That's hilarious. Okay, that might be an issue in my transport mechanism, because it actually crashed in chunked receive code, which, okay, so this end is a different bug. So if we if we can't read the response, this will be like, whatever. What is response? response is couldn't parse incoming JSON. So it's valid JSON there, but why does it crash? Oh, because we delete the error which is inside the... Okay, yeah. I'm not that familiar with the API for... Okay, let's rerun this. This will still crash, but that one shouldn't. Should render fine still. Exciting experiment. Okay, so now this one didn't crash like it's supposed, but this one did. So it just, yeah, I can parse incoming JSON. Then, yeah, client sync finished. It didn't find any valid. No, it's cool. I'll stop this. I'll show you where it crashed. Let's switch this around so you can see what's actually happening. I'm gonna set this as the worker node, like the master node. Put HDR -- nodes, and this one is. Let me check the. I don't want to show you my full IP here. So it is 192. 101, and yes. Close that. Set this to listen. Actually kind of fun to debug with two machines. Listen up and run it from here. We have the same assets on both machines roughly, but it shouldn't matter because obviously it'll send the assets. So there we go. It crashes here. And this is no longer related to what we're doing here, but I think we'll still debug since, you know, it's an hour and 18 minutes since I started, so. Okay, so responding start sync. Then can parse incoming JSON. And then we try to read more. If we send an error response, we should break. Because right now, if we get an error from the client on the worker, wait. This gets confusing fast, but basically, in the worker server, if we send an error, then we should abort. That's what I'm trying to say. Responding. Yes. Yes. Yeah. So it's supposed to do this, but also for errors. So I think we'll refactor this. We'll just make another one. Whatever. Action error. Error. If this. Yeah, if string return true. And then this one contains goodbye or contains error. That should be good. So now, set this as a worker. Start from, wait. Yeah. It still crashed on the laptop here. I don't know why that is. We'll find that out. Okay, so it crashed on both. Buff. Sigboard was not allocated. Buff. Junk receive. If buff, free buff. Okay, so we don't need to free it here, obviously. Derp. Rerun here. Sending assets. Still crashes on here, but now you see it went back to where it was supposed to be. And it doesn't free all the memory. It kind of, I think we need to let's see, we can add file cache. We'll set cached files, and then we want to send that to null. Because between these sessions, the idea with the worker node is that you can leave it on. Preferably not in an exposed network, because I'm sure it's full of vulnerabilities, but the idea is that it can, once it's done serving a single worker, it can just reset itself and then go back to waiting for connections. So it's supposed to free all the memory between runs with this worker cleanup, but it doesn't do that yet. So destroy file cache. See, it didn't do that, so we'll see what happens now. Still crashes on the laptop, so we'll switch this back around, I think, in a bit here. Yeah, so there we go, responding error, and it didn't free all the memory, but that will deal with that later. That's fine. This is still trying to delete something that it's not supposed to. Oh, it's still the same warning. Yeah, okay, so we fixed that already. Let me commit that. File cache. Get push, and we'll pull on the laptop. Stop this, and get pull. There we go. And then rerun this, see if both of them or one of them crashes. Why couldn't it parse the incoming JSON? I just realized. Okay, so neither crashed, but it didn't work. Why is that? I just realized that that's probably not supposed to happen. I'll set my laptop aside here so I can hit Command R and test this out. Or I could do it on a local machine, but whatever. For fun, we'll do it from over the network, because this didn't actually happen on the local hosts. Couldn't parse incoming JSON. Okay, which is the case? Okay, so if we don't have JSON, the only case? Add R on the laptop. Wait a little bit. It's in debug mode, so it's a bit slow. I'm gonna. Yeah, okay, so the JSON is null. That's a problem. I'm gonna set the laptop to balloon release mode. There we go. Release build, and now it's a bit faster. Yeah, there you go. Okay, so if we rerun this, now I hit return. Bam. There you go. That's much faster. Get hash mismatch. Oh, that's. Wait. 0DA 5C. Oh. I'm gonna need to build this again, and then 0DA. Alright, it's gonna, yeah. This updates the, yeah, there we go. So only running make here will update the actual gate hash in the binary, so that's fine. Now it should work. For now, I forbid trying to sync up nodes with different git hashes. That's a bit harsh. The idea is eventually to use like semantic versioning on the protocol, but we don't do that yet. So that's to do on the to-do list. Why do we not get any JSON? So the buff we get is clearly there, and we get the message. Message ends up being null. What happened here? Is that not valid JSON? It's pretty long, but if we action load assets, yes. Files. Let me dump this into a file. All right file, and it's gonna take the buff, Sterling buff, and then do maybe broken JSON. Cast this just in case. LDB is pretty strict about that. There you go. Maybe broken. Oh, look at that. It didn't get the whole thing. Well, that's no wonder. Yeah, it didn't get the whole JSON. That's a problem. It's probably in the networking layer that didn't send the whole thing. Which is annoying, because well, I only tested the networking stuff on over localhost, right? So it's very possible there's some issues there. How would I do this? How would I test that? Was there any warnings? I should I can enable these debug things. Yeah, I did test this, but only on the localhost. What if we just try and play around with the chunk size? That's half a kilobyte. Just, you know, off the top of my head. Can parse incoming JSON? Okay. Let's just let's just print out what we get. Printf will include no, don't do that. Print out the whole buff. Something like that. Oh, this is actually rendering on my laptop, because if it doesn't connect to clients, I'll still do rendering locally. Yeah, it doesn't get the whole thing for some reason. I think I'm not going to start fixing that now. We got the file cache tested, and I'll move on to I'll stop recording and try and debug this networking issue on my own time here. Still rendering on the laptop. I think that was a pretty good video. We got the file cache implemented. That works great. I mean, it doesn't work because the networking stuff is messed up, but the actual file cache worked over localhost, so that's something. Yeah, I don't think I'll start messing around with the networking stuff on this video here. If you got this far, I thank you very much for watching. I know it's been a little while since I made the last video. I think it was December, like mid-December I made the last one. I found over the years that like on a single given project, my interest in it kind of comes and goes. So for Sierra, I've been working on it for 5 years, and during that time, there have been multiple times where I just don't work on it for a couple weeks or a month or so, even a couple months. But I always come back. It's the only project that really just keeps pulling me back because there's a lot to learn, a lot to do. It's a lot of fun. But I think that's it for tonight's video. So yeah, if you got this far, thank you very much for watching, and hope to see you on the next one. Goodbye.